This is like our soil, which is a silty loam. Now, a silty loam typically has about 20% clay in it, and the rest is debris from farming, right? Little plant matter, biomatter. It also has rocks and sand, those types of things. So we have a pretty good material. And in fact, we've got one of the best building materials in the world here, and that's basalt. That big black rock around the canyon, that's some of the strongest stuff on the planet. Like, when we get into doing weights, you're going to find clay will carry about 1,500 pounds per square foot. So if I took a foot by a foot area, I can put almost a ton of material on it, and it should stay right there and not move. If I got a silty loam, I can put 2,000 pounds on there. If I'm using that basalt rock from out on the canyon, I can go down to a square inch and I can carry 50,000 pounds. It's that strong. It's just incredibly strong.
And that's before that'll start to like move, like kind of move around.
Mm-hmm. Okay. Yeah. And you know, I mentioned the clay had that kind of platey stuff. Well, one thing that'll happen is actually the clay won't settle or fail. But then I put a bunch of weight on, that weight is then going to slowly mitigate down because nothing stops this from sliding out of the way. And it'll just slide and go right down.
So say you're building in a place where, you know, you've got about, I don't know, 2 feet of soil, and then under that it's basalt. I mean, it's just the hard rock.
Mm-hmm. The big shelf of basalt.
Do they
We have it
just-
underneath us right here.
Yeah, do they clear it out and then put the concrete directly on? I've always wondered that, how they deal with the big rocks that they're planting.
We actually go right down to the rock and we pour concrete over them. All of CSI buildings, we have a basalt layer that's 6 feet below us on the CSI campus. And it's solid all the way to the canyon. And for us to put these big masonry buildings on them, we can't put them on the soil that's on top because it'll squish and move out of the way. So every CSI building, if you watch one built, they'll dig it all the way down to the basalt for the foundation, pour right on that, and then use a stem wall or a piece of concrete to go through that soil horizon where you start the building.
Do they drill into the basalt at all?
I don't think we have, no. If I had something like a tower, then I might. And no, I don't think we really do. We just go to the basalt layer and then pour from there out. Yeah, but if you want the building to last, that's what you gotta do. They also do, just so you know, you will do soil remediation. If you're on clay, you can actually take it and say, let's scalp the top 4 feet off, get rid of it, replace it with a competent soil.
Right.
You can do that too.
What do they call that?
Yeah, that's kind of what we call it, just replacing soil. All right, for our area, I do want to point one out. We have a piece of code. I want you to turn to page 837, if you will. This was one on your code sheets, by the way. This was one of the questions, and I showed you this earlier. This is a prescriptive footing method. So this will be the size of that lowest member that you're using. If you follow these guidelines right here, you do not have to get an engineer involved. Okay? You just need to follow these. Now, these are based off of people building thousands and thousands of homes in areas. For Twin Falls City and Twin Falls County, unless you do a soil analysis test, you must assume the soil is clay. Okay? Have to. Now, it only costs $400 or $500 for a soil analysis, and we have several labs in town that would go out, take some samples, do some tests on it so you can surpass it. Because most of our soil is much stronger than clay. Okay. So, this is clay, 1,500. So if you use anything in this column, now these are the widths, the thickness of it is typically 8 inches. So by that, when I'm looking at a piece of footing, well, like this is the part we're talking about right here, the lowest part. So if I've got conventional wood frame, 1 story with a roof, then I make it 12 inches wide. Okay, so that would be, this width here is 12. This 6 that we have in the code means that is the minimum thickness. Almost nobody does 6. We just call it out at 8. So that's for a single floor. Now we're doing a double floor. And our bottom floor is a concrete wall, 8 inches thick. So in that case, what we have to do is come down to this one. 8-inch solid or fully grouted masonry, 2-story. So our thick width on it is now 30 inches. So it says 29, don't do 29, they're not going to build it at 29. They're going to build it at 2.5 feet, 30 inches. Okay. So that's going to be the minimum thickness under certain parts. We're going to see both of these. We'll see this one in our crawl space. We'll see this one underneath our basement.
I thought you said we had good soil.
Oh,
We're going to
We-
the 2000.
Dude, no, we aren't,
Oh.
because we're not doing a soil test.
Oh.
And it doesn't
okay.
matter if you are on grade soil, unless you do a soil test in Twin Falls, you're using clay as your design material. That's right on their website. Okay. So, now this is assuming reinforced concrete. Okay. The concrete is not what's going to fail, the soil is what is going to fail. The other thing is water. You want to take care of water. Now, we do this in a couple ways. I'll just jump on the previous page. The best, anytime you can get to a non-mechanical system, you're doing better. You always want to engineer with nature in thought and let it take care of the problems. Yes?
You go down and you're pouring your concrete on the salt, can you jump up to the higher level, or do you still have to pay for that soil analysis?
Oh, if you're doing a building like this, $500 soil analysis test is Mock's next. Yeah, I'm doing soil analysis.
No, but I'm just saying, if you know that you have the salt and that's what you're going to do, you still have to do the soil analysis.
How did they have this?
I don't know. Yeah, to tell you the truth, I don't know.
Okay.
I don't know what the permit group would make you do. I haven't been exposed to that situation.
There has to be some tests to show there's salt, so you don't have to test somewhere, right?
Yeah, you know, look,
Yeah, so you have to know there's salt.
but I'm not quite sure. I know there's soil tests. Every time you do a building like this, the structural engineer is going to get soil tests. Whether you use them or not, whatever. So the first way to take care of water, slope the soil away from the structure. Now, you do not want this where the soil's coming here, water comes in ponds here, and then it's going to infiltrate down for groundwater. So for surface water, almost always we take care of it by sloping the soil. There is a code in chapter 4, and you want to put this on here, and it's in my notes that I will give you. You must slope by code all soil away from a structure for 10 feet at a 1/4 inch per foot. So in essence, every foot we go, we're going to drop 1/4 inch, next foot 1/4 inch for 10 feet. That is a code item. What it does, it takes care of surface water, snow melt, rain, those type of things. That's the first thing. Now, we do have another water source. We got 2 water sources we take care of, surface and underground, because we do have water that's down here. Hence, we drill wells and go get it, right? For drinking, that type of thing. We do have underground water, and we need to take care of that one. So I think 33.4, figure 33.4. Has a couple pictures on it. So the first one's basement, and here you can see I'm taking the basement wall and they're spraying a tar substance on here. In essence, it's a waterproof barrier. And all it's there for, because concrete is basically waterproof. But the concrete, there's 2 things you know about concrete, it's the old joke. 1, it's going to get hard, 2, it's going to crack. As soon as it cracks, water then infiltrates down. Now we're going to bury this thing back with soil. So if this concrete cracks in here, water then has a path to get through it. So we need a waterproof on the outside of these items. Only in living areas. If we don't have living space back here, I really could care less if water goes through it. don't care. In this case, I do, so I've got to do that. Now, the other way we do that is if we do have underground water, is we do rock or French drains. And here you see a French drain. Okay, so here's my exterior wall, right here. So my living space is on the other side. I put this on the outside. So I put it underneath the structure, where I dig out some dirt, I fill it full of rock, so that water can flow through it. So as water comes down in the soil, it creates a void, water's gonna go to that void, it's gonna be drawn to it, gets in the rock and goes. Typically, when we add a pipe to it, we call that, as soon as we add a pipe to it, we call it a French drain. And no, I don't know where the name came from, just what we call it. So a rock drain with a pipe is a French, and this is the real common one to use. The reason we use this one versus just a rock is that a lot of times we get soils that come and get into the rock and stop that mitigation of water moving through it. Okay, and this always stays open. Now, what they do on this, just so you know, there's little holes drilled in this pipe, starting about halfway high. We don't drill the bottom part of it. We want water to run in that. But then we start drilling holes all the way around halfway up. So as water gets caught in here, it goes through the pipe into the bottom and flows away.
So the top of the pipe is porous?
We call it perf pipe, or perforated pipe.
And are you laying some kind of screen over that so doesn't it clog?
That's what this is. That's to keep soils out. Those don't always work. Now, let's look at where that goes in a drawing. Let's go to 3334. So you see where that's at. Actually, 34, those show it. Let's go to 3337. I'm on page 854. So to take care of groundwater, specifically in here, they show a wood wall, but think of a concrete wall being here, basement. We're going to put soil against it. Water's going to infiltrate that soil. What we do is we put gravel against the wall. Okay, that allows the water, when it hits the gravel, to flow straight down instead of being forced this way. We then hit our perf pipe down at the bottom. That fills up with water and drains it away. Now, the thing you got to make sure of when you're doing this stuff, here's the height of my living area. That pipe, it better be below that. Okay. Or the water table will build up and go through this seam. In fact, if it was me doing this, that perf pipe would be down here. I'd put it quite a bit below it.
I don't understand how just painting the side of the concrete makes it waterproof.
It's a very thick rubberized, it's really the same stuff we use on the top of flat roofs. No, it's a thin layer.
It's not all.
I mean, because when we were out at the houses, it just looked like it was like a super thin, like a layer of paint.
Yeah, but it's still rubberized and it flexes, so that you don't get cracks in it.
Once it hardens, it's.
It never really hardens, it always stays
Well,
flexible.
yeah, they don't have to go.
It's got rubber elements in it.
Because they did.
Now,
like they did.
is this really something we need to worry about in our area? I think Sean asked the question, I didn't mean to interrupt you, go ahead, but you asked the question, how deep do we drill for wells, I think, out on the site? And I told you on that subdivision, they're going about 500 feet. And then, you know, a mile away, we've got water at 15 feet. The thing you gotta watch out for our area is you will have local underground water tables that fluctuate dramatically. So you'll go out to a house, you'll dig it up, there's no water anywhere, you do the house, 3 months later an event happens which we call charging our canals, and we've got a canal 50 feet away, now that soil's saturated because it's coming from the canal. So you need to watch out, if you got ditches around that place, I'll do this on every basement I do. Just for the simple fact I can do it for about $300, and it's a very easy insurance in case something ever happens. Somebody leaves their faucet on right here. Okay, and floods their house. Well, your house probably isn't gonna flood if you've got that sitting down there.
So basements that always flood every year don't have one of those.
Yeah, pretty much. Or this gravel has gotten compromised so it can't get there. Something's happened.
Our house was built in the 80s, and I don't think we've ever had any flooding in the we had a flood last year from we have a coulee, and it got up, it went over the banks, and our whole yard was saturated, but it's happened before, so then out of the blue, so I wonder if we have this, and it,
Do you have a basement?
that's what flooded. So I wonder
I would bet you probably do have one down there.
But I wonder if it got compromised somehow.
Could have. Over time, that's 30 years, right? Sean, you have a question?
How far do you have to run that perf pipe, like past the site of the house for that to be effective?
A lot of people will
Or is it,
tie this
is it
into their
graded?
septic system. Yes, it does have to slope away, right? And so if I was looking at this, let's look at it in plan view. Okay, so I have a corner of a house, and I'm gonna put my perf pipe right here. Right? And now where am I, your question is, how far do I gotta get it away from the house so it doesn't affect things?
Mhm.
There's a couple things. One, we'll take this many times and tie it into a sewer system. And so it just continually drains to the sewer. And it always goes away. If you're out in the middle of nowhere, where you don't have access to that, what you'll do is you'll come out here and dig a big, like, cistern underground. And then you'll fill this full of rock, and this, of course, is down here, it's down low. You'll just run that pipe to this rock thing and let it fill up. And usually we make these about the size of a 55-gallon barrel, because as you can take that, gather it, then that water will disperse out through the soil before it fills up, because we are a desert. We get, what, 11 inches of rain a year.
We have none of those.
So now your question was, how far away? In essence, I think as long as you got 3 or 4 feet away, then you would be fine. It typically takes, I did a study on this once. There's a formula for it, on how stuff infiltrates. I was dealing with sewer systems and E. coli moving through soil. And it took 20 years for that bacteria to move 100 feet. Now, so water is going to move faster than that. But as long as you don't ever fill this thing up, you're going to be good. And we don't have to make them very big. I've got them underneath my house, and they're about the size of half of your table, and they go down about 1 foot. It's just like a natural tank. And it just takes that, puts it in there, because we only get a rain event or melting snow, and then that'll fill up. And hopefully it just takes that overflow so that this water doesn't start, because if that fills up, then what does the water start doing? It starts building up, right? And then it's going to start trying to find cracks and go in. Your country, Winnemuck, again, a couple feet, and I'm sure you're good.
Yeah. After you said that, my dad dug one of those right by our house. I think he a little excess, but
Yeah, you're always better making these bigger. I mean, it's just a little shovel work, right? Gravel's cheap.
when we did it with the
So it's
jewelry.
just covered with
Okay, so you got to take care of surface water. I showed you the 2 ways we do it.
No.
Soil, do a soil test if you don't want to use clay. Other than that, you're using clay. The study of soil, by the way, is called geotechnical. That's the firm you would look for in the phone book to get
So you
somebody
said
to do a
there's
soil
2 ways
test.
to get rid of surface water? Or just slope it away from that, what's either way?
What's that?
So there's 2 ways to get rid of surface water? No, just slope it away, what's the other way?
No, just slope your soil.
Okay.
That's surface
And
water.
that's the second one.
That's snow rain.
Okay,
That's
one,
snow
two.
rain. That's
Slope.
this right here.
Okay.
Right? We're sloping that soil. You've all heard probably stories about crawl spaces getting mold and people having to move out of houses. That's almost always caused by this right here, where the soil is at. Almost always. And that's a tough fix. That's a tough fix. My mom's house was like that. We had to go tear her entire backyard out because it was too high and drop it down about 1 foot just to get that to work.
And so is that the fix for that? Do you just have to make that soil at a different angle?
Yeah, just slope it, and then it takes all that rain and snow and it sheds it away from the structure. Pretty simple fix, really. Okay, so those are the things you really got to watch out for when you're doing these, water and the soil types. Let's look at different types of foundations now, the different materials. First one I want to look at is steel. So this is figure 33.6. Page 834. Now, I will tell you, there's really no true steel foundation, although we do call some foundations steel. And here you can see it here where my columns are steel, my beams are steel, as we come through for this foundation or the supporting structure. Now, what you really don't see in this picture is that this steel is sitting on a concrete pier. Okay, and the pier is actually dispersing the weight. The steel can go in the soil, but remember, steel is a carbon-based material. Okay. So it rusts, bugs eat it. You put steel in soil, you think it's really strong and everything, and you don't protect it, it will pretty much degrade. In 100 years, it's going to be nothing but flakes of rust. Okay. So we still need to use concrete with this. But it's a great supporting structure. Steel is our strongest material in all of the facets. By that, it's good in compression, it's good in tension, although tension is its strong point. Steel is great in tension. It handles torque really well, handles shear strength also. So it's a good all-around building material, hence why we use so much of it. Wood. Now, we do put wood in our foundations, and you can use wood as a foundation. I want to look at 3317. We'll start here. Okay, now, you can use wood as a foundation. But if you do, by that, when I say a foundation, it's the closest thing to the soil. You have to use cedar or redwood. Those are the only two wood types you can use. Now, we do have another engineered wood that we can now put in contact with soil. It's called pressure tree. In essence, what we do is we take a pine or Doug fir, punch a bunch of holes in it, we soak it in an arsenic bath, so rat poison, and that doesn't let bacteria into it. Okay? It kills the bacteria when they come in and try and eat it. So by the way, when you're handling those red boards that see as pressure tree, wash your hands when you're done. Okay? Unless you want rat poison. Now, what we use it for is we use wood in our foundations as a nailing surface. We keep it 6 inches off the soil. So what you see here is you see the top of the stem wall. There's going to be a board that goes over these bolts. We're going to bolt it down to the concrete. And then we got a nailing surface to build our walls on as we go up. Okay. So we have a top one we call a seal plate. You see it in the next picture that's right next to it.
But are they going to leave that board, those wood there, or are they going to pull it off? Is that just to put it on the foundation?
Oh, that wood you see there is just the form. Okay, this wood gets pulled off. I'm talking about right on the very top, right here.
So where is, when you're saying that you're going to use wood for your foundation? I mean, where?
That's going to be right on those bolts on the top. So you're seeing the forms for the concrete. These boards on the side will go away. They're going to get pulled off.
Oh, so there's
Look
no
at the
real
picture.
wood foundation, though. That's
But
what
go to the next picture.
Yeah, look
Lisa.
at the picture
Go
right
to the
below
next
it.
picture. Which is
Well, no,
right
I
below.
understand that, but the foundation is not wood. The foundation is still concrete.
It's considered part of your foundation. So the wood portion's gone. Now that the concrete is hardened. This is what we call the seal plate. It's part of your foundation. It's the top part. Okay. Here you can see it bolted down onto those anchor bolts. Okay. right here. You might want to make a note right here in the margin of this or something. Anchor bolts do have code. I've got one here I'll pass around. So this is a typical anchor bolt that you're going to see. Okay, it's got a 1/2 inch diameter and it's 10 inches long. And the reason is that we have to have the anchor bolt penetrate 6 inches at a minimum into the concrete. And we're going to have 1.5 inches for that board to sit on, right? This is 1.5 inch board. And then we need room to put the nut and washer on. So we typically leave about 2-3 inches of this exposed. And that gives us 6 inches that goes into the concrete. And people just walk along, you'll have this wet, they'll just walk along and kind of jiggle them down in there, and then just let them dry in place. The code on this is in section 4 of the IRC. You cannot have a spacing over 6 feet. Okay, so that's your maximum spacing of 6 feet. Most people call it out 5 feet. In addition, every seal plate or wood member here has to have 2 anchor bolts at a minimum. Don't care the length. If it's 12 inches long, it still has to have 2 anchor bolts in it. Lastly, you have to have 1 anchor bolt within 12 inches of the edge, the end of the board. So those are the 3 codes you look out for. And I've actually got it in my note. If you've never seen one of these, you'll see it's threaded on top. Okay, so it's a threaded fastener. And I'll just pass it around so you can look at it.
So the 3 codes are, you have to have one less than 12 inches from the end.
Yep.
You have to have 2 together.
2 per board, at a minimum.
Oh, 2 per board. And must go 6 inches down? Or what was it?
No, we don't worry about that.